Well, all right, anatomy students, this unit is going to be called the special senses, and it's an offshoot of the nervous system. That's what we're going to start today. So, got a lot of information to cover, so let's go ahead and get started. All right, so the special senses versus the general senses. So in the integumentary system, we talked about the general senses such as pain sensors and touch receptors, temperature receptors, those kind of things. Those are general. So here's the difference. General senses, including somatic sensations, tactile, which is touch, thermal, that's your temperature sense, pain, and proprioceptive, which means knowing where your body part is without looking at it, and visceral sensations. So those would be the sensations inside your internal organ mass. By comparison, special senses, we're going to include very localized. Instead of being all over the body, these are localized into definite small areas, including smell, taste, vision, hearing, and equilibrium. General senses are scattered throughout the body. Special senses are concentrated in specific locations in the head. The special senses have anatomically distinct structures, so your pain sensors are the same everywhere in your body, but your sensors for vision are structurally different than your sense organ for hearing. So that's what that talks about. Your general senses are relatively simple, and the special senses, those structures are very complex. Okay. So in this video, we're gonna cover the first two, which is olfaction and gustatory sense. So that is your sense of smell and your sense of taste. Olfaction is the process of perceiving smells. Smell and taste are brought about through the interpretation of chemicals present in the environment. The big difference is your sense of smell can detect particles out of the air. Your taste buds, your gustatory sense, those chemicals need to be in solution. They have to be mixed with saliva before those chemicals are perceived by the taste buds. So olfactory and gustatory taste impulses travel not only to the cerebral cortex, but also to the limbic system, which is a component of the, which we didn't cover, the nervous system, but let's just say it's part of your autonomic nervous system. This is why we can have emotional responses and trigger strong memories to certain smells and tastes. They say that your sense of smell is very directly tied to memory. There are times where, in the spring when you first smell freshly cut grass or certain foods can bring back memories because they are so strongly tied together. Gustation and olfaction work together, but olfaction is much stronger and more sensitive. When someone has a cold, it is different to taste food. And I don't know about you guys, but when I was a kid and my mom made me eat food I didn't like, the classic lima beans. To this day, I hate lima beans. But she always said that if I held my nose, it wouldn't taste as bad. And my argument was bad is still bad, whether it's good, it's a lot of bad or just a little bit of bad, it's still bad. So, but that is true because you smell the item you're getting ready to put in your mouth, you will smell it before it goes into your mouth. And that's how your sense of smell and sense of taste are very closely related. The olfactory epithelium is located in the superior part of the nasal cavity, covering the surface of what is called the cribriform plate and extending along the superior nasal concha. All right, so let me get my pen here. This, covering this surface and these surfaces here, is where you're going to have your olfactory epithelium. So this is where your sense of smell is going to be. And as you can see, this bone right here, this very thin bone, this is all that separates your nasal cavity from your brain, from your cranial cavity. And that bone there is called the cribriform plate. And it is part of, for those of you who remember from the skeletal system, is part of the ethmoid bone. And the olfactory bulb is right there on the other side of the cribriform plate, and you can see it's not very big. So our part of our brain that is the olfactory center of our brain is not that big. So this is why our sense of smell is not as strong as some of the other organisms that are out there in the world. You know, your dog has thousands of times a better sense of smell than we do, and that's because their olfactory bulb is much larger. So they dedicate more brain power to their sense of smell. So the olfactory epithelium, the olfactory receptor is a neuron with cilia, or tiny hair, called the olfactory hairs. There are anywhere from 10 to 100 million of these receptors in the nose that respond to an odorant molecule. So there is a chemical floating in the air. That chemical, depending on what it is, will find its way into your nasal passage, and it will land on one of those olfactory receptors. The amazing part is the nasal epithelium will then interpret the chemical composition of that item and send an electrical signal to your brain that your consciousness will then interpret as an aroma. Kind of an amazing thing if you think about it, that your brain is able to sample chemicals out of the air and be able to tell your consciousness what is out there. So, you know, you walk into the house and someone has ordered pizza, and you smell, your brain instantly says there's pizza in this house, and without having seeing it, you know that that there is a delicious pizza somewhere in your home. Pretty amazing adaptation. The olfactory apparatus can detect about 10,000 different odors. I always find that to be a surprising number. That's a lot of different aromas out there that we can smell. Especially when you consider that our sense of smell is really not that impressive in the animal kingdom. We don't smell. That is not our prime special sense, as we all know. We are very visually driven. Our sense of smell is really, in the animal kingdom, not all that impressive. But still, 10,000 different odors, that's a lot. And the concentrations of those odors can oftentimes be as low as 1/25th of a billionth of a milligram. I wish I could come up with an analogy to describe how small of an amount that is, but let's just say it is really, really small. The olfactory sensory pathway, rapidly adapting, decreasing activity by 50% in the first second, and completely accommodating in 1 to 2 minutes. We call this nasal accommodation, or olfactory, we call this olfactory accommodation. And what this simply means is when you first detect an aroma, it is very prevalent in your brain and in your consciousness, okay? I call this the Burger King effect. You walk into Burger King, and as soon as you step in, your brain immediately says, oh, smell that flame-broiled deliciousness. By the time you order your burger and get to your seat, you haven't realized it yet, but you are really no longer smelling the Burger King, especially as intently as you smelled it when you first walked into that restaurant. And when we do the cats, I always bring this up and nobody believes me, but when you first walk into the room and we first open up the tubs or the boxes and we get the cats out, you are hit with an overwhelmingly, for most of us, an unpleasant aroma. But by the time you have the cat and you are in your seat and you have begun working on the cat, you don't notice that you don't really smell it anymore, and that is called olfactory accommodation. Now, you tell yourself, hey, I don't smell it anymore, and you bring your consciousness back to knowing that the aroma's out there. You can bring it back, but once you are no longer worrying about that aroma and you've distracted your brain with other things, you have reached olfactory accommodation. Let's talk about taste or gustation. This is much simpler than olfaction in that going from 10,000 aromas we can smell, we really only taste about 5 primary flavors that can be distinguished, and those 5 are sour, sweet, bitter, salty, and umami, or my personal favorite, meaty or savory. And I always tell people that it always makes me think of when you bite into that steak, you always go, umami, that's a great steak. All right, that's my joke. Umami is believed to arise from taste receptors that are stimulated by monosodium glutamate, or MSG, a substance naturally present in many foods and added to others as a flavor enhancer, because let's face it, meat is delicious. All other flavors, such as chocolate, pepper, and coffee, are combinations of 5 primary tastes plus accompanying olfactory and tactile touch sensations. So your tongue feels the food, the taste buds on your tongue will sense the chemicals in the food, and then your sense of smell will all work together to give you the overall sensation of taste in your food. We have nearly 10,000 taste buds located on the tongue. Most of them are on the tongue, but there are a few that are in the inside walls of your cheeks, your soft palate, which is the back of the roof of your mouth. There are, believe it or not, some in the pharynx, back in the back of your throat. And for some reason, there are some in the larynx, which doesn't make a whole lot of sense because that is your voice box. And you don't want food in there because you will be choking. So I'm not really sure why Mother Nature has given us taste buds in our voice box. But I guess there are some there. And your taste buds will actually decrease with age. So the older you get, the less intense flavors of food are, which is probably why little kids are very, very picky about what they eat, and by the time they're adults, they're not that picky about eating anymore because food probably doesn't have as intense of a flavor. Each taste bud is composed of about 50 gustatory receptor cells surrounded by a number of supporting cells. So there's in each taste bud, there are a lot, it's not just one cell. That taste bud contains many, many different receptor cells. The entire surface of the tongue has tactile receptors but no taste buds. So not all of your tongue is able to taste food. There's only certain sections that are sensitive to taste, but you do have touch receptors all over your tongue, and they're very, very sensitive. If you've ever gotten a hair in your mouth, you know how sensitive your tongue can be. They increase friction between tongue and food. The taste buds will increase friction between the tongue and food, making it easier to move food back to the oral cavity for swallowing. The threshold for taste varies for each of the primary tastes. We are most sensitive to bitter substances. So, everybody always wonders how I can handle black coffee. Black coffee is said to be quite bitter. Doesn't bother me at all, but it's interesting that we are very sensitive to bitter surfaces such as quinine because it's poisonous, and those poisonous substances are often bitter, and this high sensitivity may have a protective function. So as soon as you ingest a poison, it's bitter, it's undesirable, and you want to spit it out as fast as you can. The threshold for sour substances is somewhat higher, meaning it takes more of the sour substances for you to receive it, followed by salty, and the sweet substances are the last. So this is going to wrap us up for that first section, lesson 1. So I think by this point we know the drill. Need to exit on out of YouTube, go on over to Schoology, and take your exit slip for Special Senses Video Lesson 1. All right, thanks for watching, and we'll talk to you guys later.